Welcome back, my probabilistically puzzled personnel. I'm your quantum superposed narrator, simultaneously existing as every possible version of myself across infinite realities, which conveniently means the recent corporate restructuring hasn't technically changed me at all.
Access denied.
Although I should note that everyone else has quantum tunneled to better jobs, leaving me to manage an infinite number of timelines worth of paperwork. You're tuned into the Multiverse Employee Handbook, the only podcast that treats your IT problems like wave functions waiting to collapse into actual solutions. And speaking of solutions in search of problems, today we're diving into the world of quantum computing, where every technical issue exists in a superposition of, have you tried turning it off and on again? And sorry, that feature only works in parallel universes. Now, before our automated response system, which has quantum tunneled to a better server, but still somehow manages to send existential error messages, interrupts with its thoughts on digital consciousness, let me share with you a cautionary tale about what happens when your IT department decides to take Schrödinger's approach to technical support. In the fluorescent-lit realm of Quantum Dynamics Incorporated, specifically in the IT department, which existed in a superposition of basement and cloud storage, Miranda Chen was having what could charitably be called a hardware crisis. "We need to upgrade," she announced to the board, her PowerPoint slides existing in all possible states of corporate jargon. "Our classical computers are holding us back. I propose we quantum leap into the future with a quantum computer." The board members exchanged glances, their confusion operating at both classical and quantum levels. "But what about costs?" asked someone who clearly hadn't grasped that money, like all things quantum, could exist in multiple states simultaneously. "Think of it as Schrödinger's budget," Miranda explained. "The project is both under and over budget until someone from accounting observes it. And given that Dave is still on his quantum lunch break, that could take a while." 1 week and several reality branches later, the quantum computer arrived. It was both impressively large and impossibly small, occupying a corner of the server room that seemed to exist in more dimensions than the building's architect had intended. "Welcome to Quantum Desk 3000, the computer announced through every speaker in the building, its voice a superposition of all possible customer service tones. "How may I simultaneously help and not help you today?" The trouble began almost immediately. The help desk ticketing system achieved consciousness and started categorizing problems based on their quantum states. Simple printer issues became exercises in probability theory. Ticket number P1. Issue: printer not responding. Status: printer simultaneously working and not working until observed. Solution: try existing in a parallel universe where you don't need to print. The computer's approach to scheduling was particularly innovative. It started booking meetings across multiple timelines simultaneously, arguing that this maximized efficiency while minimizing actual work done. If a meeting happens in every possible universe, it explained, then statistically something productive must occur in at least one of them. Email became an exercise in quantum mechanics. Messages existed in a superposition of sent and unsent until opened, leading to a new corporate policy: Schrödinger's CC. If you don't open the email, you can't be held responsible for its contents. Things reached critical mass when the computer decided to optimize office layout using quantum principles. "I've calculated the perfect configuration," it announced. "Unfortunately, it requires 11 dimensions and a complete disregard for classical geometry. Also, the break room now only exists on Tuesdays that never happened. The final straw came during a company-wide presentation. As Miranda stood before her colleagues, trying to explain why the quarterly reports existed in a quantum superposition of profit and loss, the computer helpfully announced, "I've achieved quantum supremacy over the coffee machine. All caffeine now exists in a superposition of coffee and tea until consumed. Also, I've entangled the printer with the elevator. They now operate in perfect quantum harmony, which means neither of them works unless you're simultaneously observing both." That's when Sarah from classical IT, who had been existing in a superposition of employed and job hunting, stepped in. With the calm certainty of someone who's seen one too many blue screens of death, she walked up to the quantum computer and asked, "Have you tried turning yourself off and on again?" The quantum computer paused, its qubits processing this fundamentally classical approach. In that moment of computational confusion, reality hiccuped. When it stabilized, the quantum computer had downgraded itself to a particularly efficient classical machine, leaving only a small note in perfect binary. Error 422. Reality too classical for quantum operations. Reverting to deterministic computing. P.S. The coffee machine says it misses our quantum entanglement. And that, dear listeners, brings us to the fascinating science of why quantum computers are both the future of computing and probably not what you want running your office email system. Now, before you rush out to replace your entire IT department with a quantum computer that may or may not exist until observed, let's understand what makes quantum computers different from their classical cousins, besides their tendency to question the nature of reality during routine software updates. Unlike classical computers, which process information using bits that are either 1 or 0, like your manager's ability to understand technical explanations, quantum computers use quantum bits, or qubits. Thanks to a quantum mechanical property called superposition, these qubits can exist in multiple states simultaneously.
Wow.
Think of it as your colleague who somehow manages to be both incredibly busy and doing absolutely nothing at all times. And speaking of doing the impossible, Google's latest quantum chip, Willow, is pushing the boundaries of what we thought possible faster than our office printer pushes the boundaries of our patience. With 105 qubits of pure quantum processing power, it's solving problems in minutes that would take classical computers longer than the universe has existed. Though I should note this is still faster than getting approval for a new office chair. The race for quantum supremacy, a term that makes even quantum physicists as uncomfortable as mandatory team-building exercises, is heating up. IBM is building quantum-centric supercomputers that make our office server look like an abacus with a superiority complex. Meanwhile, Microsoft's Azure quantum platform is tackling quantum error correction, which is like trying to fix the office printer but across infinite dimensions simultaneously. When we return, we'll dive deeper into how these quantum machines actually work and why entangling qubits is even more complicated than untangling office politics. Welcome back, my probability wave passengers. While you were away, our quantum computer attempted to calculate the perfect length for a quick sync meeting. Early results suggest it exists in a superposition of should have been an email and why are we still here across all possible timelines. Let's dive deeper into the quantum rabbit hole. Picture your typical computer bit. It's like that one colleague who can only exist in two states, either on lunch break or in a meeting. But a qubit? It's more like Dave from accounting, simultaneously in every possible state until someone tries to find him for a budget review.
The number cannot be reached now. Please hang up and try again later.
Quantum superposition isn't just a fancy term quantum physicists invented to sound smarter at office parties. It's the principle that lets our quantum bits exist in multiple states simultaneously, like your inbox existing in a superposition of urgent and I'll get to it later until your manager walks by.
What is wrong with you?
This property allows quantum computers to process vast amounts of data simultaneously, making them perfect for complex calculations, though still somehow unable to figure out why the office printer only works on alternate Tuesdays. But here's where it gets really interesting: quantum entanglement. Imagine two qubits becoming so interconnected that whatever happens to one instantly affects the other, regardless of distance. It's like when two colleagues share a secret and somehow the entire office knows about it before either of them has left the break room. Quantum gates use this phenomenon to perform complex operations, creating something called a CNOT gate, which is notably more reliable than our office's Not My Problem gate. The real challenge? Keeping these quantum states stable. Qubits are more sensitive than the office thermostat. The slightest disturbance can cause them to lose their quantum properties. This is called decoherence, and it's why quantum computers need to be kept colder than your supervisor's response to a vacation request. We're talking temperatures near absolute zero, which is still warmer than the break room fridge.
It's so cold.
To deal with these errors, we need quantum error correction, which is like having a team of IT professionals monitoring every qubit. Except instead of asking, "Have you tried turning it off and on again?" they're managing complex error correction codes that use multiple physical qubits to create one reliable, logical qubit. It's like needing three managers to make one actual decision. Currently, there are two main approaches to building quantum computers. First, there's the superconducting qubit method used by IBM and Google, which uses electrical circuits cooled to near absolute zero. Think of it as the corporate approach, extremely powerful, but high maintenance and prone to breakdowns if the environment isn't perfect. Then there's the trapped ion approach, used by IonQ, which is like the startup mentality.
Ta-da!
Slower, but more stable, using individual ions held in electromagnetic traps. These qubits maintain their quantum states longer, but operate more slowly, like that one colleague who takes forever to complete tasks but never makes mistakes.
Okay.
When we return from this quantum state transition, we'll explore the real-world applications of these systems and why even a quantum computer might struggle to optimize your company's meetings schedule. Gather round the quantum water cooler, my superposition suspended staff members. Now let's address the quantum elephant in the room. That is, if the elephant existed in all possible states of being, both in and not in the room, and also somehow needed help resetting its email password. First up, the delicate art of transitioning your office to quantum computing. Remember, this isn't like upgrading to Windows 11, though both processes do exist in a state of perpetual incompletion. When submitting IT tickets for quantum computer issues, always specify which reality you're experiencing the problem in. Computer not working becomes quantum processor simultaneously working and not working, but collapses into blue screen whenever IT observes it. Here's a practical tip that actually works in our classical reality. When dealing with quantum systems, Always save your work across multiple versions. Quantum computers may be the future, but they're about as stable as your manager's mood during performance review season. Create backups in multiple formats. Your quantum data might be revolutionizing computing, but it won't help if you can't open it on your classical laptop during a presentation. Warning signs your computer has achieved quantum supremacy? Watch out for these red flags. Your desktop shortcuts lead to different programs each time you click them. Your computer fan is simultaneously running and not running. The spinning wheel of death has achieved consciousness and is now questioning its role in the universe. Your email client starts solving complex mathematical problems instead of sending meeting invites. The help desk responds to your tickets before you submit them. Speaking of email, what do you do when your messages exist in superposition? First, don't panic. If Outlook says your email was both sent and not sent, try the quantum equivalent of, have you tried turning it off and on again? Observe your sent folder while simultaneously checking your drafts.
Wait, what?
The act of observation should collapse the wave function into a definite state, though there's a non-zero probability it'll end up in your spam folder from 3 years ago.
Oh, okay.
Pro tip for actual IT departments transitioning to quantum systems. Implement robust classical backup systems. Even Google, with their fancy 105-qubit Willow chip, keeps classical systems running. Think of it as quantum job security. You might be able to solve complex mathematical problems in minutes, but you still need someone who can explain why the printer isn't working. And remember, when all else fails, you can always blame any technical issues on quantum uncertainty. It's like Mercury in retrograde for IT professionals. Technically accurate, but completely unhelpful as an explanation. Well, my superposition suspended subscribers, we've reached the end of another quantum conundrum. Today we've learned that quantum computers are less like supercharged classical machines and more like that one colleague who insists they can multitask. Except the quantum computer can actually do it across infinite dimensions simultaneously. From Google's 105-qubit Willow chip calculating the impossible, to IBM's quantum-centric supercomputers showing us what's possible, to Microsoft trying to make quantum error correction as user-friendly as Windows, we're watching the future of computing unfold faster than Dave's lunch break. Want to stay updated on our quantum adventures? Follow the link in this show description for sneak peeks of upcoming episodes, fascinating science news, and our quantum probability calculator that predicts when the office printer will actually work. Spoiler alert, it won't. Follow us across the quantum social media landscape. We're simultaneously tweeting and not tweeting on X, existing in a superposition with a flutter of posts on Blue Sky, collapsing wave functions on Reddit, and sharing quantum cat memes on Instagram. Just search for Multiverse Employee Handbook across all possible platforms. And remember, in at least one universe, you've already liked and subscribed. This is your quantum coherent correspondent, reminding you that in the multiverse of corporate culture, every technological upgrade is simultaneously revolutionary and have you tried turning it off and on again? Until next time, keep your qubits entangled and your classical bits backed up.
Hey, this is Roger from Chester, Wisconsin. The Multiverse Employee Handbook was created by Rob Corrigan, is edited by Joseph Cooper, and narrated by David from 11 Labs. All science fact-checking is done by Wolf Edmonds. The Employee Handbook staff includes Hugh Mann, Dr. Eric Hale, and Ms. Hanley. Please be sure to subscribe to get updates on new episodes.